simulation workflow productivity using high-performance computing cloud services. As always, we try to keep our presentations under 20 minutes to give you plenty of time to ask questions without going over the 30-minute time slot for the webinar. We will be answering questions at the end of the presentation, but in the meantime, feel free to type them into the panel, the GoToMeeting webinar panel that should be to your right. We will answer them in the order they come in. Without further ado, I'd like to turn the presentation over to today's presenter, Nimbix's CEO, Steve Hebert. Steve.
Great. Thanks, Paul, and good morning to everyone, and thank you for your time, and thank you for joining. So we're going to talk about simulation workflow productivity, and in the basically the spirit of the Compute 30 webinar series, this is focused on what we call an industry track, where we will look at industry-specific problems and evaluate the effectiveness of using HPC cloud services to support those different challenges. And in this case, when we talk about simulations and HPC workflows, it does transcend multiple disciplines, whether you're in manufacturing or computer-aided engineering or in the life sciences domain with simulations like molecular dynamics. The workflow is going to be similar, and so that's really what is going to be the focus of today's topic, is simulation workflows in general. Now, some of you are familiar with Nimbix as a company. We were founded in 2010, right about the time that cloud computing was turning 4 or 5 years old. And the challenge that existed at that time is that the early commodity cloud solutions that were designed for web services were really working to solve and bring cloud computing solutions to the marketplace. And what was missing, though, with virtualized cores and memory was a solution that really addressed the challenges unique to high-performance computing applications. And for Nimbix, that meant a focus on building a cloud from the ground up for HPC and all the way up the spectrum to cloud supercomputing. We actually built the first high-performance cloud platform that we call JARVICE that was unique in the fact that it was focused on delivering accelerated computing solutions. So not just cores and memory, but also novel architectures like GPUs, DSPs, Xeon Phi, even FPGAs for more programmable-oriented solutions. And this really was an industry-first platform capability in the cloud space. Now, we operate a public high-performance compute cloud, which means that users from across the world can submit tasks to our cloud to leverage the HPC clusters that we operate. But we also manage dedicated high-performance compute clusters for our customers, and think of it as sort of a private cloud or a hosted cluster solution, where we will help manage and operate those clusters for our customers. And increasingly, we see a hybrid approach where there's a little bit of both between dedicated solutions as well as the public cloud solutions. And today, those are served out of our Dallas data center for high-performance computing, and soon, later this year, to be in Houston, Texas, and then ultimately expanding outside of the Texas market into other regions around the world. So let's talk about some of our simulation challenges. And I think whether you're working on workstations or operating existing cluster environments today, we wouldn't argue that there's a simulation challenge related to the growing problem sizes. And whether you're trying to simulate a larger number of molecules or denser cells in a mesh for computational fluid dynamics, the problem sizes are getting bigger. And what that means is that the computations are running longer and consuming more compute cycles. The other big challenge around this is directly related to those growing problem sizes, and that's one of inadequate resources. And that may be because you're constrained to a workstation-based environment, or perhaps your small cluster is not large enough to tackle the increased workload. And what we see a lot of customers doing is actually settling for reduced fidelity in their simulations just so they can get the work done. And that's a bit of a pain point because it's a sacrifice on accuracy and fidelity to be able to get the problem even solved. And ultimately, these things translate to a slower time to innovate and discover. We're settling for slightly less accuracy because it's what we can consume, and ultimately, we can oftentimes lose competitiveness. So with respect to simulation, let's start with a typical workflow in the simulation domain. And there's generally 3 broad steps in the process. There's a pre-processing phase where the user is either setting up the model or the solution or the solve for running the simulation. This could be in an interactive desktop type of environment before a batch job is submitted to the workstation or HPC cluster on premise. Then there's the simulation, which is the computationally intensive part of the solution, usually the long-running piece. And this is generally going to consume a significant compute resources to enable us to get our work done. And then the final phase is post-processing. And the post-processing is basically analyzing those results and working interactively with the data that's been generated from the simulation to draw meaningful conclusions, to make discoveries, and to invent new products. And this is ultimately the cyclical workflow for product development as well as scientific discovery. So the question that we're asking today is, can the cloud help with the simulation workflow, and can we improve productivity? The question we come back to is, can we reduce our simulation times while we at the same time handle larger problems? And can the cloud give us both the advantages of compute capacity as well as a visual environment to interpret or analyze those results that are computed in the cloud? Can we continue to invest and enable collaborative simulation? Increasingly, we find that staff members are scattered throughout the globe, and the simulation workflow needs to be collaborative. Can the cloud assist in that as a platform? And then finally, and this is a problem both inside and outside of organizations, centralizing data management. How do we handle the glut of data that's being generated both in the prep and post-processing phases around the simulations? The Nimbix Cloud supports the simulation workflow with a process that we call build, compute, and visualize. And Leo introduced this in our HPC 101, and we'll actually do a deeper dive in a later Compute 30 webinar on the specific kind of deep dive on each of these components. But for today, keeping it kind of industry and high level, this maps quite nicely into the simulation workflow that we just discussed. So when you think about the build phase, whether you're building or enabling the actual applications in a cloud, or simply building and designing your models or setting up the simulation with an interactive cloud environment to do your prep side of the process. The compute phase, which is really about scaling out to high-performance computing resources to get those simulations done faster to support that simulation phase of the workflow. And then finally, visualize, which is the ability to visually interact using a remote 3D workspace to talk to the data that was computed in the compute phase, and leveraging a platform that can actually offer all 3 of these components as part of that workflow. So let's walk through using the platform to get meaningful work done. And to begin with, you see some screenshots to the left with the, highlighted with the compute phase. And the idea here is to show how simple it is for industry important applications around simulation to simply choose the application and the level of computing scale you want to get your work done. It's as simple as taking your data, your inputs, and getting your answers back in the least amount of time. So when we talk about improving simulation productivity, the whole point of the Nimbix platform is to make this process and that workflow seamless, easy to consume, and ultimately drive your productivity up. So we try to keep things simple by eliminating complex installations and orchestration of cloud resources to actually get your work done, to really minimize the amount of custom configuration you need to do while offering a cloud infrastructure at the base that meets the most rigorous high-performance computing requirements. So you can think of it as really purpose-built for high-performance computing as a cloud service. So when we come to the compute phase of the process, running simulations in the Nimbix Cloud is a batch process. We'll talk about some advanced features in terms of on-demand clusters in subsequent webinars, but today the focus is really thinking about the compute phase as a batch process for getting your larger scale computational work done. In that process, whether you're interacting with an API or our web portal, which is depicted here, you're simply selecting the application and the command for the simulation that you want to run, and this would be for one of your preferred vendors on the application side, or even an in-house simulation application, or even an open source simulation application that might be offered in our cloud. You'll configure specific parameters, choose the amount of compute scale you want, and so this would be basically either cores or compute nodes to help you, essentially get your answers back faster. And then finally submitting that as a job or task in the Nimbix Cloud. So to talk more specifically about the workflow and the specific steps, the very first step in leveraging these kinds of resources is to get your data to where the cloud lives and preparing that data. And Nimbix supports 3 secure methods for moving your input files. The most popular right now is secure FTP using a third-party client like a FileZilla or a WinSCP to securely connect to your Nimbix data repository and transfer files. And this is a fairly fast and efficient and secure way to move data. You can also use native clients inside of Linux desktops or other operating systems to move your data. One of the other capabilities we recently introduced was the ability to use a Windows share over an encrypted HTTP connection. Now this mechanism, which is depicted to the left, is actually pretty easy to use, but it does run a little bit slower in terms of data transfer, and there are some actual file size limitations with respect to this transfer method. And then finally, arguably the most powerful way to transfer data is to use the Nimbix API to automatically handle your data movement. And in this regard, the user would specify the endpoint of that data, whether it's a secure FTP server on-premise or some other remote cloud. The Nimbix API will fetch the data prior to launching the processing task and automatically start that task. And so this is very useful for streamlining or pipelining workflows where data needs to be moved and orchestrated behind the scenes. So now that data has arrived, we start the process of prep, post, simulate, and post-processing. And you'll start that typically by running an interactive session for pre-processing. And in this example, we are showing one of our application partners, Ansys, which is a leader in the computer-aided engineering and fluid dynamics space, how easy it is to launch a remote visual resource for this pre-processing stage. And you'll notice that the parameters are simply requesting your desktop resolution, which is your local monitor desktop, and the application specific for the task you want to, the application you want to run in that graphical environment. And this will essentially launch on demand that environment for you to begin your work in the interactive mode. Now, the second step of the process is the actual simulation. And in this example, we've snapshotted an application called Fluent, which is a fluid dynamics package from Ansys. where we will collect a set of required parameters, and many of our workflows also offer optional parameters that can be passed in for running the simulation. And in this case, it's as simple as an input file which has the set of commands to run for the simulation as well as the data file associated with that task, and then any other required parameters for the application to be able to consume. Now you'll note that you can select the number of compute nodes, which can vary of the amount of scale, and also helps you select whether you're going to run, shorten the length of time of your simulation. So the more, in many of these applications that are linearly scalable, the more the more scale you select, the faster your simulation will run. Finally, the post-processing phase, you'll run the interactive session again like we demonstrated in the prep phase. And this is simply a screenshot showing the graphical nature of the 3D environments. And this does require, has specific requirements around connectivity for end users with respect to bandwidth and location in terms of user experience. But the net effect is the performance and graphical acceleration that Nimbix is able to provide in our cloud gives users the flexibility to use this as a remote visualization workspace for their post-processing, where you can interact with your 3D models seamlessly from pretty much anywhere. And this even eliminates the need for big workstation environments under your desk. And you can, even we've experimented with using tablets and mobile devices for leveraging these environments. Now I'll say a few words about high-performance computing requirements for simulation, and we talk about improving productivity, and one of the ways we improve productivity is by bringing more compute scale to the table. And the HPC requirements typically we think of are bare metal performance. We want to typically steer away from virtualization because it has a penalty in terms of performance, and the whole reason we build HPC environments is to go faster. And as we increase core counts, we need to have the high-speed, low-latency interconnect, like InfiniBand, to help scale those computations across lots of compute nodes. And then finally, a growing number of application vendors are supporting computational accelerators like GPUs to improve the speed of their solves for the simulation phase. So companies and partners like CST and Ansys now have support for GPUs to accelerate those, and Nimbix has these already built into our cloud performance infrastructure. And for those of you who attended a couple of weeks ago when Leo talked about the cloud platform JARVICE, just to say another few words about the platform itself. And it all starts with the infrastructure at the very bottom of the stack. And for Nimbix, that infrastructure is not just cores and memories. It's also these computational accelerators that can be leveraged by applications to speed up processing performance. And it does all this while supporting the 3 phases of a simulation workflow, whether you're in the design phase or development and building with respect to your product development and pre-processing environment, to the compute phase, to the post-processing and visualization, all from a single platform. Now, as we look at the actual cluster capabilities, I want to highlight a couple of points that are useful to know when you're considering simulation workflows. And from a cloud standpoint, one of the benefits of using HPC Cloud is because you can get access to state-of-the-art hardware to speed up your processing. So even in some cases, users may have access to clusters, but they may be 2 or 3 years old, and simulations may still take a little longer than what could be achieved with state-of-the-art or latest software releases, etc. And so with Nimbix, you're going to get the latest Ivy Bridge processors, of course, the high-speed, low-latency InfiniBand interconnect, and then recently introduced is the latest and greatest K40 GPUs from NVIDIA, which are extremely powerful in accelerating a large number of workloads, as well as offering incredible performance from a graphical standpoint. Now, from a functional standpoint, it's really important to bridge these HPC attributes to the actual simulation workflow. And the Nimbix Cloud supports both batch and interactive, as we've discussed, with the Build, Compute, and Visualize platform. We also automate license management and make it very easy for commercial software vendors who may use flex-oriented licensing approaches to make it very easy for end users to consume the infrastructure and capabilities of the platform without complex orchestration with respect to licensing. I talked about the automated data movement, but a word on processing workflows is even though we show and we offer these rich portal environments for running your workflows, all of these are scriptable with the Nimbix API. And again, in subsequent webinars, we'll do some deep dives on the technical track for achieving this with your particular workflow. So I'll say, make some comments about security, and because cloud security is a common area of concern when interacting with cloud resources. And the Nimbix Cloud, of course, in addition to a data center that is SSAE 16 and SOC 2 compliant and 24/7 monitoring and secure with double authentication, all of the actual network access and transport is over encrypted transmission. And we also add another layer with an API key for authentication for any data transactions that are interacted with our cloud. And then finally, importantly, is we do two other unique things relative to other cloud solutions. Is we offer workload isolation, which means that in the simulation environment, no two workloads will be operating on the same compute node. So those environments stay physically and logically isolated. And then finally, we offer we call it behind the firewall processing. You don't have to spin up an expensive virtual private cloud network solution to take your compute nodes off of the public internet. All of our compute is done behind the firewall, so they're not publicly accessible when those workloads are in flight. So let's talk about some specific examples. And the first one is in the life sciences domain from a European research organization where there was a large data set, and the main problem was that there was inadequate resources to get the computation done. In other words, the computation on existing resources would have taken a very long time. And the answers were needed more quickly than the compute capacity allowed. So we did two things in this case. We accelerated the application with GPU, which it just so happened that we had an application that had been optimized for GPU. And with the incremental scale that the cloud could offer, we reduced processing time from 400 hours to 40 hours at a cost of $109. And the second example is in the manufacturing space with a fluid dynamics problem, a fairly large model with an average runtime of similar model sizes of around 11 hours when running in-house based on in-house resources. So this had the challenge of both, again, a more complex or larger problem size and somewhat limited compute scale from an in-house. And so with the Nimbix solution here, it was really adding simply scale, reduce the simulation time. And in this case, we were able to reduce it to under an hour for a whopping cost of $6, which is, I think, almost less than you can buy a Big Mac for today. So pretty amazing what can be achieved. And the idea here is to really drive that efficiency and productivity up. So as we conclude, looking at improving productivity with JARVICE, it provides a single cloud platform for all of the workflow phases, the pre-processing, the simulate, the post-processing, and in the Nimbix sort of vernacular, the build, compute, and visualize, which allows that entire workflow for really any HPC workflow, but also specifically for simulation. And the automation is there to make it simple to consume. So part of what JARVICE tries to solve is not just giving you compute resources. It's about giving you all of the software tools and automation to make your work easier to consume those resources. It's a lot of options for customization. So to get started, you can contact Nimbix to set up an account or create one at our portal at nac.nimbix.net. You can also please reach out to us directly and request a meeting if you'd like to discuss something with one of our team members and review your specific workflow requirements. We're happy to help talk through the ways that you can apply JARVICE to your specific workflow to help you increase your productivity. So with that, thank you for your time, and we'll have a little bit of time here for a question and answer.
Thank you, Steve. We are opening this up to questions. We've got a few listed already, but if you'd like to ask a question, please enter it into the panel, the GoToWebinar panel. It should be off to your right, and we'll answer those. We did run a little long on the presentation, so if for some reason we're unable to answer all of your questions, we will contact you directly via email and make sure we get that answer out to you. Our first question we have is, how do you support the use of customers' own proprietary simulation software?
Okay, great question. So today, using JARVICE, and we talked about build, compute, and visualize. The build component of JARVICE is not only does it help with the simulation workflow in terms of using existing applications, but it enables users to actually create what we call Nimbix application environments with that software application stack embedded in it, and that can be snapshotted. And so once that build piece is done, it can be used in batch mode iteratively to run the larger scale computation. So it's a very efficient way to actually get proprietary simulation code in our cloud for use in a purely on-demand basis. So you don't have to actually, when you run it in batch mode, worry about turning on and off machines. You simply use our API to run your proprietary software in batch mode to run the computation. And we're doing that with numerous customers today. And Paul, I would add one other comment on that is, if you have specific questions about how to get started with that process, we're here to help. So please reach out and we'll walk you through that process.
Great. Thank you, Steve. Next question is, how does the software licensing work?
Yes. So I talked about licensing briefly, but there's a few ways that licensing works. The first I'll start with, because it's the most common, is with certain commercial software vendors who use traditional flex licensing methods. We fully support a fully orchestrated flex licensing server for an account or user based on licenses acquired from the software vendor. So this is a bit of a bring your own license model where you would purchase a short lease or a long lease, the license key from the vendor. You have that linked to a host ID on Nimbix, and then you would upload, and Nimbix would host that license for you, which then gives you access to whatever infrastructure on demand your license allows for. So that's one of the more popular ways we interact. Now, we also support licensing models where the software it's a fully integrated license where it's simply a pay-per-use, all embedded in an hourly rate, and so then you just consume what you consume and you pay per use. So we support each of those different models, and if you have a specific question about getting started with a specific application vendor, let us know. I didn't show screenshots, but if you do log in and set up an account in the Nimbix portal, you will see with specific applications a command called license management, and you can actually use that to run and start to set up one of those bring your own license arrangements.
Thank you, Steve. Next question is, how can I monitor the simulations as they run?
Okay, that's a great question. So that question comes up because when you're launching in a cloud in a batch environment, it almost feels like it's going into a black hole and you're not knowing what's happening while it's running. And the answer is actually we do provide a few tools for allowing you to interact with the simulation as it's running. The first is what we call live tailing, where with specific applications we provide an icon on our portal from a processing standpoint that you can simply click on, and it shows the output file as it's being created. So in the case of, for example, CAE type workflows or CFD, You can see if your solution is converging properly. If it's not, you can abort the job and kind of reset up your solution and so forth. Now, the other way is to do that on a slightly more manual basis, because as output files are generated, they are created in your NAC repository, your data repository on Nimbix, and you can actually connect to that account at any point out of band and check the progress of your simulation. And then finally, one other kind of teaser is our soon-to-come capability where you can use the interactive piece to actually check the progress of your simulations interactively using a GUI. And that's something that we are working with some application vendors to support and enable as well to, again, make it very easy at any point in time to check the status.
Thank you, Steve. We are actually right at the top of the hour, and I want to thank everyone for attending. I know we do have a few other questions we will be that we haven't gotten a chance to answer yet, but we will be reaching out to you individually and helping to answer those questions for you. If you do have any other questions for us, please feel free to contact us and via our website or via email. Also, for those of you, I noticed a few joined after the session had already started. We will be posting a recording of this session on our website. It'll be available in about a day or so to view. It'll be at Nimbix/compute30. Sorry, Nimbix.net/compute30. Again, thank you for your time, and thank you, Steve, for your presentation.
Sure thing. Thanks, everyone, for attending.